Hi all, welcome to my YouTube channel, Know About Embedded System. In today's video, we will discuss how to generate interrupt from pulse width modulation. Before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video here. So guys, in the previous video, we have discussed how to generate interrupt from SPI, EVOT and timer and external source. Today we will discuss about pulse width modulation interrupt generation. So you know that already in the previous videos, I have already explained what is pulse width modulation and how to develop a code for pulse width modulation. So now we will concentrate how to generate interrupt from pulse width modulation. Here, so let us assume this is my pulse width signal. This is my PWM signal where we have on period and off period and total time period. So what is this? You can just watch my previous video. You will understand what is on time and off time and total time. Now, how to generate interrupt for a pulse width modulation? So here, the pulse width modulation interrupt can be generated with respect to total time period. So it is similar to timer interrupt generation only. There is no much differences between PWM and timer, but there is a slight difference. So here, MR0 will hold total time duration. In our pulse width modulation, MR0, that MR stands for match register 0, will hold a total time duration T is equal to T on plus T off, and MR2 or MRX, you can say, like MR1 to MR6, there are different match registers are there. Those match registers will hold a duty cycle, nothing but on time period. Okay, so whenever you want to generate interrupt from the PWM, we have to generate with respect to MR0. So whenever TC reaches to MR0 value, what is TC here? TC stands for timer counter. Basically, pulse width modulation is also, it's a timer based application. So here also we will have a timer counter. There will be a main timer counter. Whenever the main timer counter reaches to MR0 value, it is possible to generate an interrupt from the pulse width modulation. So this is the main thing, how to generate interrupt from the PWM. So whenever timer counter reaches to MR0 value, it is possible to generate an interrupt. Okay. So to generate interrupt in the before going to the coding, I'll just go to the user manual here. So this is pulse width modulation control register PWM MCR, that stands for match control register. You have to configure your pulse width modulation in an interrupt mode, especially with respect to MR0. Here you can see bit number 0 talks about interrupt enable configuration PWM MR0I, that stands for interrupt on PWM MR0. Okay, so interrupt will be generated whenever MR0 matches with a TC value. This is what I have told you. Whenever TC matches to MR0, it is possible to generate interrupt. So now in the code, what we have to do? We have to enable MR0 in a interrupt mode. This is the one important thing we have to keep it in mind. The next one thing here is we have to discuss with the PWM interrupt register that this is a latch enable register. This is control register. This is CCR. Yeah, here you can see this is your PWM interrupt register. Okay, this register we have to clear the bit number 0. Okay, so whenever there is an interrupt, this bit will set bit number 0 of your PWM IR register, nothing but interrupt register bit number 0 will set. We have to clear this bit in an interrupt service routine. So two important things. One is we have to configure MR0 in interrupt mode, and whenever there is an interrupt, we have to clear the interrupt register bit. So two things we have to keep it in mind in understanding the coding. So coming to the coding here, coding it is nothing but our regular PWM configuration only. There is no difference, but we have added 3 important additional configurations that I'll explain you right now. So this is your PWM configuration function. So here again I'm repeating here. Already PWM program I have already explained in the previous video. I will update the link in the description box. You can just watch PWM programming part. Okay, I don't explain completely here. So now the scope of today's video is to understand the interrupt. Line number 56. Here you can see. Line number 56 talks about configure MR0 in an interrupt and a reset mode. Right? So in the previous programming, regular PWM programming, we have enabled only in a reset mode, nothing but repeat mode in the previous coding. But today, what we are doing, we are also enabling bit number 0 of your MR0, indicating that we are going to enable interrupt, and also we are going for reset mode. So both configurations we have enabled. So this is a one important thing to configure PWM in interrupt mode. And the second important thing is, as usual, NVIC configuration. We have to enable interrupt from NVIC as well. Here you can see NVIC enable IRQ, and then enable PWM interrupt. Enable PWM interrupt, and then set some priority here. Set some priority to your PWM. So these two statements will configure your NVIC. So this is the second point we have to know. And third point, as usual, pulse width modulation handler. PWM handler. Here I'm just printing saying that there is an interrupt from PWM, and clear the interrupt. Here I'm clearing the interrupt of your PWM. Three additional things we have added here, and rest all the things are same. Okay, so now I'll just show you the main code here. So this is your pin function selection, and this is your PWM configuration. This is your integer main. This is clock configuration, UART configuration, PWM configuration, and in while of one, I'm generating different duty cycles of your pulse width modulation: 25%, 50%, 75%, and 95%. And this will be kept it in a while of one, so that it will be running continuously and continuously for every 1 second. One more important thing. So I kept it your MR0 for 1 second. Total time I kept it as 1 second, so that we can observe very clearly output. So this time I did not go for 10 milli. This time I'm going for 1 second. So 1 second MR0, and 25 millisecond, 50 millisecond, sorry, 250 millisecond, 500 millisecond, 750 millisecond, and 9.5 millisecond, 0.95 second. So like this, I'm going to generate different PWMs with interrupt. I'll go to the debug window here, and I'll show you output in the debug window. Okay, so this is your logic analyzer, and I'll just keep it in a vertical mode. Yes, so I don't want. Okay. So this is, I have already kept configured, and this is your UART. I'll just allow to run here. Yeah. So this is my UART where you will get output, and this is your PWM signal, PWM peripheral. See here, after completion of one cycle, it is able to generate one interrupt, and the interrupt will be updated in this part. Whenever there is an interrupt, interrupt flag will be updated here. Observe very carefully, and you can check all three parameters. This is my PWM. Now you can see it was turned on and turned off, right? And on the other hand, the PWM signal continuously generating. In the PWM peripheral, it is continuously running, and in the interrupt part, in the interrupt service routine part, it is going to print PWM IRQ when there is an interrupt. Okay, observe very carefully. So we have enabled interrupt, we have enabled reset as well, and observe this point very carefully. This is interrupt flag. Yes, I hope you have observed here. and there was an interrupt, and when as soon there is an interrupt, UART terminal will print that saying that there is an interrupt. And at the same time, here the different PWM signals are able to generate continuously. Okay, so in this way you can generate interrupt from the pulse width modulation as well, and you can execute your ISR whenever there is an interrupt. So I hope this video is also clear. So if you feel this video is an informative video, please click on like button and subscribe to my YouTube channel.